Hello and welcome. Today we're going to learn about integration of rational functions by partial fractions, also known as integration by partial fractions. Now, to get started, we want to review the method of partial fractions that you learn in pre-calculus, and we'll do a warm-up example of that. So the idea about the method of partial fractions is to take a complicated fraction and break it down into simpler fractions. So like is done right here with 5x minus 3 over x squared minus 2x minus 3. That can be broken down into these two fractions, 2 over x plus 1 plus 3 over x minus 3. Now that's going to be really helpful in a moment when it comes time to integrate this original fraction. Instead, what we could do is break it into the smaller fractions and integrate term by term each of the smaller fractions, and that'll be much easier to do. So let's get some practice using the partial fraction technique. We'll go over how to use it, what the different cases are, and then we'll get into integrating rational functions. So example 1 says expand the quotient by partial fractions, and the fraction we have is x squared plus 4x plus 1 all over x minus 1 times x plus 1 times x plus 3. Now it turns out the form of this partial fraction expansion is going to look like this. Oops. Squiggly equals a over x minus 1 plus b over x plus 1 plus c over x plus 3. So basically, each factor, excuse me, each factor down below is going to get its own fraction. And above each of the fractions, we have some letter. We're just using a, b, and c. And these are representing unknown quantities. So these are some numbers. They're also called undetermined coefficients because we haven't determined them yet. Let's go ahead and find them. Let's determine them. Determine the undetermined coefficients. So the first step we're going to do is multiply both sides by x minus 1 times x plus 1 times x plus 3. What that's going to do is clear out all of the fractions on both sides of this equation. So we're multiplying both sides of this equation by essentially the LCD of all the fractions, which is always going to be whatever is on the bottom of the original fraction. When we do that, the left-hand fraction is going to clear, and so we'll just get x squared plus 4x plus 1. And then on the right side, where all of the little fractions are going to disappear because what we're multiplying by has all of the factors of the little fractions. So when this distributes to the first fraction, the x minus 1s will cancel, and we'll be left with a times x plus 1 times x plus 3. So a times x plus 1 times x plus 3. When it multiplies to the second fraction, the b will still be there. The x plus 1s will cancel, and we'll be left with x minus 1 times x plus 3. And then when it distributes to the third fraction, the c is still there. The x plus 3s cancel, and we're left with x minus 1 times x plus 1. Now at this point we have two options. One is to expand everything out, combine like terms, and then match the coefficients of like terms, and that's the option that we're going to use first. The second option we'll cover in just a moment. That's where we're going to plug in a couple of special x values that are really going to help make things easier. Let's go with this first method because sometimes this will be the preferred method. We're going to go ahead and multiply the x plus 1 times x plus 3. We'll get x squared plus 4x plus 3. We'll do the same thing with x minus 1 times x plus 3. So we'll get x squared plus 2x minus 3 there. And then x minus 1 times x plus 1 gives you x squared minus 1. Just realized you're mostly looking at the top of my hair here. Oh well, that's the way it is. Either that or every time I look up you're going to be looking at my nose. So now what we're going to do is distribute the a and the b and the c, and we'll end up with let's see, we'll leave the left-hand side alone. So we'll end up with ax squared plus 4ax plus 3a plus bx squared plus 2bx, or not to be x, minus 3b plus cx squared minus c. Okay, now what we're going to do is match the coefficients of like terms. So you can see how there's, combine the like terms. So you can see how there's an ax squared, a bx squared, and a cx squared. What we could do is bring those all together and factor out the x squared. So I'm leaving the left side alone. Factor out the x squared from those, and you'll get parentheses a plus b plus c times x squared. So it's like we combine all the x squared terms together and then just factor out that x squared. We can do that with the x terms as well. So we've got, let me choose a different color. We've got the x terms here. If we put those together, factor out the x, we'll get 4a plus 2b times x. And then lastly, we've got the constant terms. So that's going to be, let's see, go brown. I got to work on my color coordination. Future videos. So then we've got plus 3a minus 3b minus c. Now the next step is, in order for these two sides to be equal for all values of x, the coefficients of the like terms have to be equal. So the coefficient in front of x squared on one side has to equal the coefficient in front of x squared on the other side. And that's what's going to create a system of equations that we'll be able to solve. So let's get started with that. So first off, so many colors. All right, we'll go with this one. So first off, the coefficient of x squared on the left side is 1. The coefficient of x squared on the right side is a plus b plus c. So we can write an equation that equates those two. A plus b plus c is equal to 1. Then we'll move on to the x's. So I'll go ahead and write the 4 in front of x on the left side has to equal the 4a plus 2b in front of the x on the other side. So 4a plus 2b has to equal 4. And then the constant terms also have to equal each other. So here we get, scrolling down, 3a minus 3b minus c has to equal 1. So here are the three equations that contain our three unknowns, a, b, and c. And we can solve a system like this. I'm just going to solve it in a couple of quick steps here for you. So first off, notice that we have 4a plus 2b equals 4. That equation already has just two variables. So that's going to go in our smaller 2x2 system. So we'll go ahead and copy that one over here. I'm just going to write it using blue. 4a plus 2b is equal to 4. So that one we're just copying down because it's missing a variable, missing an unknown, and so we can use that for our smaller 2x2 system. Now if we can get another equation that has a and b in it, then we'll have a 2x2 system that we can solve. So it's like we reduce the 3x3 down to a 2x2, and then eventually a 1x1 equation. One equation, one unknown that we'll be able to solve that unknown for. Now we have to eliminate the variable c to get just an equation that has a and b. And thankfully, equation 1 and equation 3 have a plus c and a minus c, so we can just add these two equations together. So what we'll do is we'll write, we're going to do equation 1 plus equation 3. And when we do that, we'll get 4a minus 2b equals 2. Right? A plus 3a is 4a, b minus 3b is negative 2b, and then c minus c is just 0, so those cancel, that's what we wanted. And then 1 plus 1 is equal to 2. So that's a smaller 2x2 system. Now what we can do is go from the 2x2 down to a 1x1 by, again, eliminating a variable. And here the b's are ripe for being eliminated. Just add the two equations together, and we'll get 8a. The b's will be gone, and then equals 6. So we get a equals 6 over 8, which is 3/4. Now you can go back and take that value of a, plug it into either of these two equations that have just a and b in them to get b, then take a and b and plug them into any of these equations, well, I guess either the first one or the third one, in order to get c. So I'm just going to write what you get when you do that. You get a equals 3/4, b ends up being 1/2, and c ends up being -1/4. After you do that kind of backwards plugging in. So now what we can do is write up our answer. The original fraction, x squared plus 4x plus 1 over x minus 1 times x plus 1 times x plus 3 equals, now all we're going to do is substitute back in the a, the b, and the c into the original breakdown that we had. All right, I'm just keeping an eye on my computer stats here if it looks like I'm looking over to the right side, because last time I tried to record this video, the computer completely crashed all of a sudden. So just keeping an eye on the temperature, the memory, making sure everything's happy, so hopefully this video can go through to the end. All right, you didn't need to know that. So 3 over 4 x minus 1 plus, putting the b in, we have 1 over 2 x plus 1, and then minus, because c is negative, 1 over 4 times x plus 3. In fact, this is right exactly where it crashed last time. So there's the partial fraction decomposition for the original fraction that we had in example 1. And I'm going to stop it right there so that we can get a video that's not going to crash. And in the next part, we're going to look at a different way of solving that same equation that's a little bit faster when you have linear factors like we did just now. So thanks for watching, and I'll see you in the next part.